Okay, example 7. Here we want to estimate the proportion of students who support legalizing marijuana. Okay, if we take a random sample of 400 and we have 272 successes, or 272 people that want to legalize marijuana, then here we're being asked to make a 90% confidence interval for this situation. Okay, so let's just record some things that we have here. The sample size was 400. The number of people that supported legalization was 272. From this, we can make a sample proportion. Okay, so this is just x divided by n, which is 272 divided by 400, or 0.68 as a decimal. Okay, also note here that we want 90% confidence. Okay, if we're starting with our normal distribution, in the middle what we're saying is we'd like 90% of the data to fall within the middle so we can get the confidence interval, or these two endpoints. Notice that we do have 10% left over of error to share. Okay, let's put half of the 10% into the upper tail, half of the 10%, which is 5%, into the lower tail. Okay, so here we would like to find these two z values that correspond with these end points. Okay, a few ways to do this. You could either do this with Minitab or with your z table. Okay, your z table, of course, is a cumulative distribution. It starts from the left, and then goes from the left and goes to the right here. So if we're looking up this 0.05 value, then we would like to find here this negative z alpha over 2 value. Sorry. So if we see which value corresponds with this 0.05, we'll find that it's in the negative 1.6 row, and it'll be in between 0.04 and 0.05. Okay, so here the negative z alpha over 2 value then is negative 1.645, and therefore the positive z value is 1.645 with a positive sign. Okay, from here we can just go and use our formula of how to find a confidence interval. This is p hat plus or minus z alpha over 2 times by p hat times by q hat, which is 1 minus p hat, and divide by n, and here this is under the square root. Okay, here's the formula that we need to use. Okay, we do have p hat. We just calculated it to be 0.68. Okay, you can either use that as a decimal or as a fraction. So here we'll put this in here, 0.68 plus or minus our z value that we found to be 1.645 multiplied by 0.68 and 1 minus 0.68 divided, of course, by the standard, by the number of samples. Okay, so here's the formula. If we carry this out, first, of course, with the negative side, you'll find that the value you get here is 0.6416, and the positive side you'll get 0.7184. Okay, and the meaning of this here is that we are 90% sure, or we're 90% confident that the true population proportion, which is p, falls between 0.6416 and 0.7184. Okay, let's see how to do this in Minitab really quickly. Okay, for Minitab, we're going to go to Stat, Basic Statistics, 1 Proportion. Here in the summarized data, we put in the number of successes, or the number of events. That's 272. The number of trials is 400. Make sure to click on Options. Make sure to input your confidence level as is required. So here we wanted 90%. And also another important thing, if you want Minitab to use the normal distribution, which is the z value, okay, that's how we calculated it by hand. So if we want to have the same answer in Minitab, we need to make sure that this box here saying that we're basing this on the normal distribution is checked off. With that, you can press OK, and find here that you get the same answers that you got as we calculated by hand.